than 4,000 are formed from the digits 1, 3, 5, 8, and 9 without repetition. So part A, how many such numbers are there? So we're looking at numbers less than 4,000. So let's break it down based off digits. So for one digit number, there's going to be 5 possible choices because it's either 1, 3, 5, 8, or 9. For a 2-digit number, there is 5 choices for the first number, 4 choices for the second number. That's going to give me a total of 20 numbers. Now for a 3-digit number, I still have 5 choices for the first one, 4 for the second one, and then 3 left over for the last one. So it's 5 times 4 times 3. That's going to give me 60. Now for the 4-digit number, this one is tricky because we want it to be less than 4,000. So the only choice we have for the first digit is either going to be a 1 or a 3. So there will be 2 choices for that. Now for the second number, that's going to be it's going to be 4 left over, and then 3, and then 2 left over. So we do 2 times 4 is 8, times 3 is 24, times 2 is 48. So in total, we add 5 plus 20 plus 60 plus 48. That's going to give us 133. Now in part B, how many of them are odd? So again, let's break it down by number of digits. So for one digit, there's 5 total. There's 1, 3, 5, and 9. Only 1, 3, 5, and 9 are odd. So that's going to be 4 out of the 5. For a 2-digit number, we're going to work backwards. So what does it mean to be an odd number? Well, the last digit has to be odd. So there's only 4, we said, digits. There are 4 of the choices are odd, and then the remaining, there's 4 numbers left. So if we choose one of them, there's 4 left. That's going to be a total of 16. For a 3-digit, we're going to start in the ones place. There's 4, and then we have 4 and 3 left over. So it's 3 times 4 times 4 is 48. And then for a 4-digit, we need to be careful again because it's either going to be, there's going to be 2 cases really. Either the first digit is 1, or the first digit is a 3. So that's going to be 2 choices here. So basically, we start off with 4 odd numbers, 4 odd digits. One of them is going to go in the first place, so that leaves us with 3 in the last place. So now we selected 2 out of the 5 digits, so that means there's 3 left over, and then 2 left over. So we do 2 times 2 is 4, times 3 is 12, times 3 is 36. So if we add these up, 4 plus 16 plus 48 plus 36, we end up with 104. Okay, now in part C, how many of them are divisible by 5? Remember, the choices are 1, 3, 5, 8, and 9. The rule is it has to either end with a 0 or 5. And it has to be obviously bigger than 0. So for this one, there's only 1 5, so it has to end with a 5 basically. That's going to be the rule here. So for 1 digit, only one of them works, which is 5. For 2-digit, it needs to end with a 5, so that's 1 choice. And then I don't care what the first digit is, so that's going to be 4 numbers left over. So it's 4 times 1 is 4. And then for 3-digit, it has to end with a 5, so that's 1 choice. And then that leaves us with 4 digits and then 3 digits. So 3 times 4 times 1 is 12. And then finally for 4 digits, remember it has to start with 1 or 3 because it has to be less than 4,000. So that gives me 2 choices. Has to end with a 5. So now we have taken 2 numbers away. There's 3 remaining, and then 2. So 2 times 2 times 3 times 1 is 12. So if we add these up, so you have 1 plus 4 plus 12 plus 12. That's going to give me 29. Now for part D, we want to see how many of them are divisible by 3. So let's look at 1 digit. So from 1 through 5, 8, and 9, only 3 and 9 are divisible by 3. So that's going to be 2 digits. From the 2 digits, this one's a little tricky. So you want to look at all the pairs of numbers. So you can have, and again, the order, I don't really care about the order just yet. So you can have 1 and 5, 1 and 9, 3 and 9, 3 and 5, 8 and 1, or 8 and 9. So if you add these up, 1 plus 5 is 6, that works. 1 plus 9 is 10, that doesn't work. 3 plus 9 works. 3 plus 5 does not. 8 plus 1 works. 8 plus 9 does not. So we have 3 of them working, and then you can change the order. So like, this one we'll read it as 15, 39, 81, and then you can just switch the order. So 51, 93, 18. So clearly that's going to be 6 available. So 6 of these guys are odd, or divisible by 3. And then we move on to 3 digit. So this one, we need to look at all combinations of 1, 3, 5, 8, 9. That works. So to save some space, we have 1, 3, 5 works, 1, 3, 8, 1, 5, 9, and 1, 8, 9. So all of these will work. These are all divisible by 3. So we can, have 1, 3, 5. We can have 1, 5, 3, etc. There's going to be a total of 6 because there's 3 numbers. The way to rearrange all 3 numbers is 3 factorial. So each one of these guys will have 6 altogether. So 6 plus 6 plus 6 plus 6, that's going to give us 24. And then moving down to 4 digit. So this one's a little tricky. So we're going to do 2 cases. First case, the first digit is a 1. The second digit is a 3. And then I guess what we could also do is, so the ones that will work is basically you would have 1, 3, 8, 9, 1, 3, 5, 9, 3, 1, 8, 9, and then 3, 1, 5, 9. So all of these guys will be divisible by 3. So the number of ways to rearrange these, well, if 1 is already taken from these guys, there's 3 numbers left over. So the way you rearrange 389 is just 3 factorial, which is 6. Same thing with 359, 189, and 159. So again, you get a total of 24 different numbers. So to add these all up, we have 2 plus 6 plus 24 plus 24. That's going to give us a total of 56. And that's our answer.